Hello students, and welcome. In this video we're going to go over some topics that you need additional help with in preparation for the final exam. So one of the topics that we're going to do comes from chapter 4. Okay, so just looking at the announcement with the list of topics on the final, it was from section 4.2, which says that we're going to calculate probabilities for a binomial random variable, and we're going to use the binomial calculator and stack crunch to do that. Okay, so we're going to look at some examples from Study Guide 2 on chapters 3 through 5. And one of the problems is number 36. So if you view the study guide, you notice that the questions are organized by section. And you'll see the list of sections as you scroll through the questions in the study guide. So we're looking for the questions in section 4.2. Okay, and we start with question 36. So that's the question we're going to look at. So number 36 says, assume that male and female births are equally likely, and that the birth of any child does not affect the probability of the gender of any other children. So we want to find the probability of at most 3 boys in 10 births. Okay, so this is the type of question that you're going to answer with the binomial probability distribution. So anytime you deal with the binomial probability distribution, there are only 2 outcomes that we're looking at. In this case, boys and girls. Okay, the probability in this case of getting a boy does not change from birth to birth. And then the outcome of one birth, boy or girl, does not affect the outcome of the other births. Okay, so those are some of the requirements for a binomial random variable. So when you look at these problems, you just want to be aware of whether it's binomial or normal or something else. Okay, so now we're going to use the binomial distribution to answer this question. So what I'd like to do before we solve the problem is go to stack bench. Okay, in a stack crunch, what we're looking for is the binomial distribution calculator. So you can find it by going to the stat menu, calculators, then click on binomial. Okay, and so we can figure out, okay, what do we need to put into the calculator to answer the question, right? So we need the value of n, the value of p, and then the number of successes that we're looking for. Okay, so according to the problem, we're going to find the probability of at most 3 boys in 10 births, and we're assuming that boys and girls are equally likely. Okay, so boy and girl are the only 2 outcomes, and the 2 outcomes are equally likely. Okay, so we're focusing specifically on getting a boy. Right, so the question is, right, what is the probability of a boy? Right, so the probability of a boy is our probability of success. Okay, so since they're equally likely, okay, the value p, which represents probability of success, okay, is going to be equal to 1/2. Right, so getting a boy is one of the outcomes out of 2 possible outcomes. Okay, so it's just 1 out of 2. And if you want, you can put that in the calculator, so 1 divided by 2. Okay, so we'd have to convert that into a decimal, so 1 divided by 2 is 0.5. Okay, so the probability of success is 0.5. Okay, the other thing you need to know is the number of trials. Okay, that's represented by n in these types of problems. Okay, so in this case we're looking at births, right? So we're looking at 10 births altogether. Okay, so n equal 10 is the number of trials. but in this context, for this particular problem, right, a trial is a birth. Okay, so we have 10 births. All right, and then how many successes are we looking for? So it's important to understand the keyword there, at most. Okay, so the words at most, okay, mean less than or equal to. Okay, so the number of successes x, okay, is less than or equal to 3. Okay, so we need to input this information into the calculator to get the probability. Okay, so n is 10. We don't need to change that. The probability of success is 0.5. We don't need to change that. Okay, so since at most means less than or equal to, we're going to select the less than or equal to symbol. And we want less than or equal to 3 births, so we're going to change that 5 to a 3. And then click compute, and then the probability will appear in this box here. Okay, I'm going to go around our answers to 4 decimal places. But when you read the problem, right, pay attention to how many decimal places they want. It may be 3 or 4 or maybe 2. In any case, read the problem carefully to figure out how many decimal places you need for your answer. So rounded to 4 decimal places at 0.1718 or 19. Okay, but that if you round it properly, that 8 gets rounded up to a 9. So the probability in question is 0.1719. So that's the probability of getting at most 3 boys in 10 births. Alright, we also have the answer key. So we can look at the answer key to see if we're on the right track. Okay, so this is number 36. Okay, so it looks like they rounded to 3 decimal places. They got 0.172. Okay, so the 3 decimal places, which is what you would need. Okay, that 1 gets rounded up to a 2, so 0.172. Okay, and when rounded to 3 decimal places. Okay, and that completes question number 36. Okay, so we're going to go and take a look at the next one, so number 37. Okay, so it says, assume that male and female births are equally likely, and that the birth of any child does not affect the probability of the gender of any other children. Okay, so the births are independent of each other. And it's one of the conditions for a binomial random variable. So the question is, find the probability of exactly 8 boys and 10 births. Okay, so again, pay attention to the key wording. Okay, so the probability of success is still 0.5. We're still looking at 10 births altogether. Okay, so we want to know, okay, what is the probability of getting 8 boys and 10 births? Okay, so again, this is a binomial random variable problem. Okay, so we're using the binomial distribution to answer the question. Okay, so since P and N are going to be the same, right, the only thing that's changing is the number of successes that we're looking for, which is 8. Okay, so it says exactly, right? So what does the word exactly mean? So exactly means equal to. Okay, so the number of successes x is equal to 8. Okay, so when we input this into stack wrench, okay, N and P are still the same. We're going to change the symbol to equal to, and then update this to an 8. So compute. So the 4 decimal places, the probability is 0.0439. Well, 0.0439. Okay, or let's say we rounded it to 3 decimal places, it would be 0.44. Rounded to 3 decimal places. Okay, and we can check that with our study guide answer key. So number 37. If you look closely there, right, our answer is 0.044, which is what we got. So that completes problem number 37. Okay, let's go and look at the next problem, okay, which is 38. So it says a recent survey found that 70% of all adults over 50 wear glasses for driving. So on a random sample of 10 adults over 50, right, what is the probability that at least 6 wear glasses? Okay, good. So the information of the problem, right, is supposed to tell you, okay, whether this is a binomial random variable or some other kind of random variable. Okay. But for the sake of time, right, this problem can be solved with the binomial distribution. Okay. So remember, we need to find the values of n and p, just like we did in the other problem. Okay. So again, how many people are we looking at altogether? Okay, that's going to be n. Okay, so in this case it says in a sample of 10 adults, right? So n equal to 10 is our sample size. Okay, but using the terminology of the book, right, or number of trials. Okay, what is the probability of success? Well, so what we care about is, you know, whether the person wears glasses when they drive. Okay, so again, according to the problem, it says that 70% of all adults over 50 wear glasses when they drive. Okay, so our probability of success is 70%. All right, we're going to want to convert that into a decimal. So to go from a percent to a decimal, you take the percentage and divide by 100. The easiest way to do that. You probably do that in your head, but we get 0.7 or 0.70. Okay, and we're looking for at least 6, right? So the words at least means greater than or equal to. Okay, so the number of successes x is greater than or equal to 6. Okay, we're going to input that into the calculator in StatCrunch. Okay, so our number of people or number of trials is 10. Okay, our probability of success is 0.7. And we're looking for at least 6 successes for 6 people who wear glasses out of the 10 people. So we're going to update that 8 to a 6 for compute. Okay, so in 4 decimal places, our probability is 0.8497. Okay, or 0.850 rounded to 3 decimal places. Okay, and you can check that with the answer key. So number 38, the answer is indeed 0.850. Okay, so let's do one more problem before we finish the video. Okay, so this next one is not in the study guide. Okay, but you'll probably see something like it on the final. Okay, so it's related to the previous problem. So find the probability that the number of adults over 50 who wear glasses is between 3 and 7 inclusive. Okay, so the wording in the problem indicates that the number of successes is between the numbers 3 and 7, including the numbers 3 and 7. Okay, so in StatCrunch, right, whenever you're asked to find the number of successes between two numbers, okay, select the between option. Okay, enter the correct value for n, the correct value for p, because those are not going to change. Okay, and then type in the lower number in the left box and the upper number in the right box, click compute, and then you have your probability. So in this case it's 0.6156 when rounded to 4 decimal places. So the probability is 0.6156 or 0.616 rounded to 3 decimal places. So in doing these types of problems, always make sure to enter the correct values for n and p, and keep in mind that the number of successes x can never be larger than n.